Axially loaded columns. Introduction. Column. If a compression member whose effective length is greater than third least lateral dimension, it is called as a column. Normally, columns are subjected to axial compressive force, but sometimes it may be subjected to moments on one or both the axes. Strength of columns depends upon shape, size and cross-section of column and length. Types of loading. Axially loaded columns. Columns subjected to loads acting along the longitudinal axis or centroid of column section. Eccentrically loaded column, that is uniaxial loading, loads which do not act on the longitudinal axis of the column section. Eccentrically loaded columns with biaxial loading. If the eccentricity is with respect to both the axes x and y, the column is said to be under biaxial loading. Reinforcement requirements for columns. Requirements as per IS code 456-2000. For longitudinal reinforcement, the cross-section area of longitudinal reinforcement shall not be less than 0.8% and shall not be more than 6% of the gross sectional area of the column. Minimum number of longitudinal bars shall be 4 in rectangular column and 6 in circular columns. The bars shall not be less than 12 mm in diameter. Spacing of longitudinal bars along the periphery should not exceed 300 mm. Transverse reinforcement. For lateral ties, the pitch of the lateral ties shall not be more than the least of the following. The least lateral dimension of the compression member should be 16 times diameter of the longitudinal bar of 300 mm and diameter. The diameter of the lateral links or lateral ties shall not be less than 1/4% diameter of the largest longitudinal bar 6 mm, whichever is more. For helical reinforcement, the pitch of the helical reinforcement shall be greater than or equal to 75 mm and 1/6 times the core diameter of the column, but should be less than or equal to 25 mm or 3 times the diameter of the helix. The diameter of the helical reinforcement shall not be less than 1/4 times the diameter of the longest longitudinal bar, 6 mm. The minimum eccentricity in columns. According to IS 456-2000, all the columns should be designed for minimum eccentricity. The minimum eccentricity is equal to unsupported length of column by 500 plus lateral dimension by 30. E minimum is equal to L by 500 plus D by 30, where L and D are in mm, and E minimum should always be greater than or equal to 20 mm. The assumptions in design of compression member. The plane section normal to the axis remain plane after bending. The maximum strain in concrete at the outermost compression fiber is taken as 0.0035 in bending. The maximum compressive strain in concrete in axial is taken as 0.002. The tensile strength of concrete is ignored. Short axially loaded columns. Here the figure shows rectangular column section subjected to axial load. The column is subjected to an uniform strain of 0.002 and uniform stress of 0.446 FCK. Axial load where E equals to 0. PU is equal to PUC plus PUS, where PU is equal to 0.446 FCK into AC plus FS into ASC. Fy is equal to stress in steel corresponding to the strain of 0.002, 0.87 Fy for Fe250, 0.79 Fy for Fe415 and 0.75 Fy for Fe500. IS code adopts the critical value of 0.75 Fy for all grades of steel for finding out the pure axial load carrying capacity of the columns. PU is equal to 0.446 FCK into AC plus 0.75 FY into ASC, which is approximated as PU is equal to 0.45 FCK into AC plus 0.75 into ASC, where AC is equal to area of concrete in column and ASC equal to area of steel in compression in column. If A minimum is less than is equal to 0.05 D, PU is equal to 0.4 FCK into AC plus 0.67 FY into ASC. The column with helical reinforcement. As per IS 456-2000, the strength of columns with helical reinforcement is equal to 1.05 times strength of column with lateral ties is equal to factor load by 1.05.